All right, one more little video here about magnetics, magnetic fields, and magnetic flux. The fact that a change in magnetic flux will produce an electric field. Okay. Now, this kind of goes back to the last video that had the little U-shaped piece of wire in here, and then there's this particular conducting material, okay, some sort of conductor in here. If we were actually to put ourselves in the position of the conductor, inside the conductor there are some electrons. Well, as an object moves through a magnetic field that's pointing out of the paper, okay, so again, if we're using our right hand rule, your fingers would be out of the paper, okay, not the curl rule, by the way, I just can't get my whole hand under there. Your fingers would be up, your thumb would be to the right, and then the top of your hand would be pointing up, which means the force on an electron would be up the conductor. So if you have a conductor and you're moving through a magnetic field, you end up building up negative charges on one end and positive charges on the other. Well, if you have a buildup of negative and positive charges, then that means what you've created is an electric field that runs from positive to negative inside the conductor itself. Okay, now a refresher here. The electric field, by definition, is the force per unit charge. Well, we also have an expression for force by a charge moving through a magnetic field. So this is the charge times the velocity times the magnetic field. So if I go ahead and make the substitution QVB in for F, I can get an expression for the electric field created by a moving conductor simply as V times the magnetic field, the velocity times the magnetic field. Okay, and keep in mind too that this electric field this way will always be perpendicular to the magnetic field out. Okay. Also, the electric field is also in the same direction as the induced EMF, from the positive to negative conventional. Okay.